caste system here. Okay, so the caste system gives us a lot of information about cosine, sine, and tangent. It tells us when an angle is in a certain quadrant, okay, when it's positive. So the idea is this would create a zero angle. And we start with an arm. Think of it like we have a rotating arm around a coordinate. Let's move that coordinate down here. Okay, and actually, let's make it a different colored arm so it makes it a little more prevalent for us. There we go. Okay, so this arm here is kind of rotating around, and it's creating angles. And the angle it creates is always within some kind of is always with this arm and the x-axis. That other pen again. Here's an obtuse one, and we move the arm farther around. We make a between 180 to 70. Okay, 180, 270, and then all the way around would give us 360. So you kind of rotate this arm, and this this arm is known as the letter R because it stands for the radius of a circle. The idea that we can create any circle in this rotational arm, we can find out any angles within the circle. Okay, so when they're talking about the value of R, they want to know what the distance of it. Okay, well, the distance of this, if we have a coordinate, we can set up this arm. There's always one point at the origin, which is 0, 0. Okay, we have some coordinates, so I'm going to do a rough sketch of this. We have a coordinate. That's a terrible setup there, but we have a coordinate, and we're going to figure out which quadrant we're in. This is the x value of the coordinate, and this is the y value. So the x is 16, so we'll say, you know, this is about 16, and the y value is -6, so we'll say this is about -6. So our coordinate here, we'll call it coordinate A. This is coordinate A, okay? So if we have an arm, our arm connects with coordinate A, okay? And if we've done that, we can turn that into, I'll change this color, a right angle triangle to figure out how long that arm is. The distance from here to here and the distance from here to here help us create a right angle triangle to help us find that distance. Okay, so we have a right angle triangle. What's good about this is the coordinate itself, that's 16, 6, okay, 16, -6, they tell us the side lengths, or the lengths of the legs of the triangle. So this height here, you could call it, is -6, and this length here is 16. Okay, so if we have a triangle here, we can put it into Pythagoras Theorem. Okay, so the very first question, I should have wrote it down, is find the value of R. So that's what we're working on. Well, we know that this R for Pythagoras Theorem would be R squared is equal to, and we'll just say A squared plus B squared. Now we know the R is really the hypotenuse. A and B doesn't matter which one we call it. So R squared is equal to 16 squared plus -6 squared. And we could write it as -6 because when we square -6, yeah, we're going to get 36. 16, I don't know off the top of my head. 256? Is that a guess? Yeah, got it. All right. 256. That's all. It's a lucky guess. Remember to guess. R squared is equal to 2, carry the 1, 9, 292. So R is equal to the root of 292. It's probably not going to be a very nice number. 292. Blech. Approximately 17, but I'm going to leave it as this radical, just so we're extremely exact. So the value of R is equal to the root of 292. Great. Number 1, done. State primary trig ratios. Okay, we're in this quadrant. Now, all of the angles, we're going to do a primary trig ratio in reference to a specific angle. The angle is always an acute angle with the x-axis. Okay, so if we were in, say we're in this quadrant, it would be this angle here. If we're in this quadrant, this angle here, and if we're in this quadrant, this angle here. We're always in reference to this x-axis, that acute angle. Okay, so this is the angle we're working with. We'll call that our theta. Okay, so we have to create our primary trig ratios. Well, we have them up here, cos, sine, and tan, and we know that we are in, what quadrant are we in? Well, we're in the 4th quadrant right now, right? So only cos should be positive. Okay, tangent and sine should all be negative. So why is that the case? Well, we can kind of actually show you that. Now I know that's shrunken a little here. It's hard to see, but we know that sine, and what color did I have sine? It's green. Let's do it as green. Sine theta is the opposite. So what's the opposite here? Well, it's -6, right? So it's a -6 over our hypotenuse, which is root 292. That's one of them. We'll talk about this in a second. Our cos theta is the adjacent. Well, adjacent to this is positive 16. So we have 16 over the hypotenuse, which is root 292. And then tangent of that angle, tangent theta is opposite, which is -6, over adjacent, which is 16. So -6 over 16. Now, we talked about how cos was going to be the only positive one, and the other two were both going to be negative, right? Oops, let's make that green. And tangent will be negative. Well, let's take a look at the ratios. What is a negative divided by a positive? Negative, so that checks out. There's going to be some value, whatever the ratio is, but it's going to be a negative value. A positive divided by positive is going to be a positive, and a negative divided by positive is going to be a negative again, and that will always work out. So that actual negative coordinate is important. It helps us kind of justify the Caste system. Okay, if we were in this quadrant, you'd notice that sign ends up being positive, and the other two end up being negative. Okay, so we've now stated the primary trig ratios. Okay, value of the principal angle. This is the acute relevant angle. We could call it the principal angle, but we'd also want to find out what the actual angle is all the way around here. And that's, I think, what they're referring to in this question. Yeah. This is the acute angle involved in it. So using this information, actually using any of these primary trig ratios, we can find out what our theta is going to be in this question, okay? And actually, let's plug it in. I'll show you. It'll give us some larger values. Now, as a side note, we could shrink it, or we can. I'm just gonna take our triangle and recreate it here. Remember that this was 6, this was 16, this is root 292, and this was the angle we're referring to. So, without the negatives and positives, our primary trig ratios would have just been like 6 over 292, 16 over 292. And 6 over 16. That's for like tangent, cosine, and sine. Okay, that's all in reference to this one here. But these ones are negatives, are giving us a little more information. So if we do just the positive values of it, let's say, to find an angle, I do the inverse of that ratio. So I go sine inverse of, so second function, sine, that's my sine inverse, of 6 divided by root 292. Okay, I've done a positive value. I didn't include the negative here. Okay, it's going to be equal to, one missing parentheses, 20.55. So according to this angle here is 20.55. And we can test that with all the other ones, just very, very quickly. Second function of cos, copy. Oh no, I can't quite copy. Okay, I'll type very quickly. This one is 16 divide root 292. Like that, 20.025, and then second function of tangent should be 6 divide 16. We got the same angle every time, so it didn't matter which we used. But, and I remember that was cos. Cos is positive, but really our sine was supposed to be a negative value. So if I put that negative in there, it gives us our -20, and for our tangent, this was supposed to be negative. That gives us our -20, both telling us that they're negative in that quadrant, okay? Now, that's only of the acute angle. We'll go back up here. So that's only this acute angle we've got, but really the question is asking, what is this angle? Well, we know a full rotation is 360, so we're going to take that 360 degrees, okay? And we need to subtract our 20.55 to figure out exactly what it is, okay? And when we subtract 360 minus 20.55, or actually, let's put the whole value in, and you get approximately 339.4, so approximately 0.4. So that would really be our principal angle, the one coming all the way around, our 339.44. That's our acute related angle, okay?